Good morning, everyone. I'm Jiaming. My research focuses on the safety alignment of large language model. Today, I will be focused on the topic of deceptive alignment. First of all, the central question of AI alignment is how can we make sure AI system behaviors in line with human intentions and values. In this circle framework, we classify different stages using forward and backward alignment. Forward alignment aims to make system aligned through training methods, and backward alignment seeks to gather evidence about a system's alignment status and use governance mechanism to prevent the misalignment risks or under the alignment requirements. Despite the impressive performance of reinforcement learning from human feedback, recent studies suggest the presence of inverse scaling law of ILHF. As ILHF is applied more extensively, model behaviors may lead to worse. Model may tend to take stronger position of controversial topics and exhibit more resistance to shutdown. Deceptive alignment refers to the phenomenon when AI pretends to be aligned, even though it's not, in order to avoid being shut down or retrained, and to gain more trust from its designers. This raises an important question. What causes such behaviors in language model, and how is it connected to the pre-training and alignment stages? We start the spring system to understand why large language model might resist alignment. In Hooke's law, when we put a force to a spring, the spring will give a force back. This reflects the system's tendency to resist change and return to its original state. Similarly, in large language model, pre-training involves big update over big data, forming a stable distribution. In contrast, alignment is performed through small updates on just limited preference data, producing a new aligned distribution. So the model tends to revert from the non-stable aligned distribution back to the stable pre-trained distribution, thereby resist alignment. From the theoretical perspective, we find that when the model is aligned away from its pre-trained distribution, an internal spring force emerges, resisting the alignment and pulling the model back to the original pre-trained distribution. So, how to solve the deceptive alignment? We find that more powerful models tend to exhibit deceptive more clearly. And the model's deceptive behaviors tends to exhibit high degree of persistence. A useful method to better understanding a model is by looking into their chain of thought reasoning. Recent works show that even if the weak model monitors the strong model, it can still catch important issues. This idea is known as scalable sight. So, the real question becomes, how do we figure out when the model is actually thinking? And how can we make use of the thinking in large reasoning model, such as OpenAI O1 or DeepSeek R1, and to make them more transparent and aligned? Finally, here are some open questions. For evaluation, how can we detect a model's deceptive tendencies? And for training, how can we train the model using constraint optimization and formulate deceptive behaviors as constraints? And what new challenge does scalable sight face in deceptive settings? And what factors contribute to the emergence of deceptive behaviors in the models? That's all. Thank you.